right. Good morning, Whitney.
Good morning.
How are you?
I'm well. How about you?
Great.
Good.
Well, since you're here and you're usually the only one who's here, let's just go ahead and see if you have any questions.
All right. I actually just sent you a screenshot of number 3 on the quiz.
Okay. All right. Let me
Yeah.
pull that up.
And it's, I think, so it's similar to the one that we worked on the other day, but what I'm not even getting an answer. That's one of the choices.
Okay.
And so I'm wondering, is there, when you're using, I'll wait till you get the question, I guess, is maybe a better.
I didn't.
You didn't get it?
Oh,
Okay.
Did you send me a screenshot on Zoom? Is that where it is?
Well, I sent it into your tncc.edu email.
Huh. Okay, but it's number 3 in the quiz, you said?
Yes.
Okay, let me just look at that.
I can also send it in the chat. Just copy the question if that's easier.
Now let's see if I can number 3. I'm getting there.
Okay.
Number 3. Okay. That's the one about galena is the ore, blah, blah, blah.
Yes.
Okay. Let me take a picture of it and then I'll come back to the calculation. I think I can see that. Okay.
So the part that's tripping me up is that it feels like I should use the ratio of galena to lead oxide somewhere
Okay.
in the equation.
All right.
But that's not helping. It's not making
All
the
right.
answer right for me either.
Okay. So we've got 1 mass of galena.
So we're looking for the
Which
mass.
is, okay, so we've got, our given is 975 kilojoules, right?
Yep.
Okay. And I guess galena is the ore. Okay, so galena is PBS, right?
Yeah.
Okay. All right, so here's the thing. You've got negative 827.4 kilojoules for every 2 moles of galena. Did you get the 2 there?
I had, I divided by 3 there.
Because
I wonder if this is the,
yeah, if you look at the mole coefficients for each of those, for instance, that ratio would be 3 moles of oxygen for that much heat.
okay.
Okay, everything else is 2. So that delta H is for that substance and its mole coefficient in the balanced equation.
Okay.
So let's see if we get the correct answer. 1 mole of PBS. Do you know how many grams that is off your top?
I had 239.2, so 207 and 32.
Okay, that looks good. And then, wait a minute, we don't need grams. Yes, we do. PBS. Okay. And then there's 2 PBS for every 2 lead oxide. And then 1 lead oxide, I'm kind of abbreviating here, is
207 plus 6.
okay. Okay.
223.
Oh, there's my calculator. I was using it with my grandson last night. Okay. He thought my calculator was pretty cool. Okay, so 975 times 2 times 239 times 414 divided by 827 times 2. Ew, I did something wrong there. Times 2 times 239 times 414, enter, divided by 827 times 2. What? What am I doing wrong? Kilojoules to 414. Oh, I forgot. No.
I think the 207, so the 2 moles, the last 2 conversion factors are flipped, right? So the 1 mole PBS, so PBS
You're right.
should be
You're
on the
right. You're
top.
right. Yep. Okay, grams.
Minus 2.5.
Okay. Mole. Okay. Well, we don't really need this. We don't need that.
Okay.
And then we want 2 PBS gives us 2 PBO, and 1 PBO is, did you say 207 for PBO?
223.
243?
223.
223. That doesn't make wait a minute. What's lead?
Lead is
is
207.2.
Okay, yeah, okay, that makes sense. Okay. So 975 times 4 times 223 divided by 827 times 2. Yep, that is, we're pretty close to the answer. The answer, I think I didn't really, let's see, 2 moles, 827. Is that right? 827.4. I got 525. Let me do that again.
I got 525. If I take out everything after the second conversion factor, so if I go 975 and then 2 moles over negative 827 and then
Yeah.
232 over 1, then I
Yeah.
get negative 563.7. So that at least matches, and it matches one of the answers on the thing.
Well, this is just, that 2 and 2 are just going to cancel out, so that shouldn't matter. I think I put something wrong in the calculator.
Is the
2 times 223 divided by 827 is, I'm still getting 525. Oh, wait a minute, 9. No, I forgot to divide. Hang on. This calculator's getting a little stuck here. Times 446, enter, divided by 827. I'm still getting 525.
so if it's just the mass of galena, do we need to carry through the PBO, the lead oxide? So I guess that was my question in the beginning.
What mass? Oh, I'm sorry. I thought we were.
So it's not mass of lead oxide.
Oh, I did it backwards. It's this. And then you want, I'm sorry, I did it backwards. And then what's the mass? Yeah, that'll be right. And then this is 243 or something, or
239, yeah.
239. Okay. See, you did figure it out by yourself. Times 239, enter, divided by 827. You're crying out loud. Now I'm getting 532. Okay, PBO is a 1. 975 times 2 times 239 divided by 827. 563.5. 564.
All right.
There we go. Okay, so was this the part of the mystery that you were struggling with?
Yeah, I think I just,
Okay.
to be honest, fat fingered it on the keyboard. I mean, it said 3 moles in my notebook too, so I just copied it.
Oh, okay. Okie doke. So you
And it's
understand
funny
that
because
whole
I've done it
process.
6 times through now, got a
Yeah.
different answer every single time, trying to
Okay.
figure it out. And really, I should have just gone back to the question.
Yeah. Okay. Well, that's easy to do. All right. Well, you're definitely going to have a problem like that on the test. That's good that you asked.
Okay.
So what else?
So
Let's see
my
if I-
other question, I think this is just a concept question, but so specific heat, there's a question in here in question number 2 that says you wanted to warm a room. Would you choose a variety of metals and then water, which obviously has the highest specific heat? So when I think of specific heat and we're thinking energy to warm the water, then I'm also inverting that and saying it will take a longer time to cool down. So if I was warming a room, I would want something that cools slower, right?
Yeah, you do.
Okay, so that makes sense to me. I just, because it's like, oh, you can heat this really quickly, so you get like instant gratification from the metals.
Right. Now here's something you can do on your stovetop. You can, and there's no way to get just water on your stovetop. It has to be in a pan. But put that, well, you could just say, put the pan on the heat, put the water in there. And if it's possible to have the same mass of each, fine and dandy, but because the amount matters, but which one is going to cool off quicker. And that's kind of a bad analogy because the water is going to keep the pan hot. But, if you think about it, let's think about this. You're at the ocean, and the sand warms up really fast, right?
Yeah.
Okay. And the water really doesn't warm up. It might warm up, a little bit, even in a lake. But then at night, how does the water feel compared to the sand?
Always
The
warm.
the sand gets cold very quickly, and the water doesn't even hardly cool off at all. It just kind of stays the same. It feels better to get into the water.
Yep. Okay.
So there you go.
That makes, I just wanted to make sure that I like conceptually understood
yes, that is exactly right. That is exactly right. So the lower the specific heat, the more heat you need to warm it up. So water is really, really high. It's 4.18. So you need a lot of heat to put into water, a lot of joules of energy to put into water.
Yep. Okay.
Is what, 16 times higher. So you've heard that saying that says a watched pot never boils.
Yeah.
Well, it's kind of true. It takes a lot of energy to get water to boil.
Okay. That makes a lot of sense. And then my final question was enthalpy. So the first time we talked about enthalpy two Zooms ago.
Okay.
In my notes, I wrote down. So we were calculating bond energy.
Yes.
When we added it up, we gave the products a negative energy and the reactants a positive.
Yes, and that's probably not the way your book does it.
Okay.
I do it a different way because of the fact that I've been teaching high school for many years. Can you see my writing? Yeah. There we go. Okay. So your book probably says products minus reactants or something like that, and make the products this and make the reactants this and blah, blah, blah. Here's what I do. If you just, because bond energy in the tables is always listed as a positive number, because when you're using bond energies, you have to make the reactants a positive number and the products, because they're produced and heat is released, it's negative. Okay. So when you take those bond energies for the reactant and make them positive, and you take the bond energies for the products and you make all of them negative, all you've got to do is just add those up. Okay.
Yeah.
That's it. That's all you need to do. So you don't need to worry about that equation where it's like products minus reactants and the summation of it, you know, and all that.
Yep.
So you don't need to do that. It's just much easier to do that. The products are negative, the reactants are positive.
Okay.
You got to put heat in, you got to add energy to break a bond, just like breaking a pencil. And for products, it's released.
Okay. That makes sense. Then if you're using moles, so they gave us one really weird one that the first portion of the reactant is written out with like the H and the bonds and all that.
Okay.
And then it says plus 2 H2. So
Yeah.
if you're using moles in that, do you
Okay.
multiply
Tell me.
that?
Yes. Do you know which number you're talking about?
It's number 7.
Okay, let me just get that because it's much easier for me to talk. Okay. Okay, I think what I'm going to do is draw this out for you because it'll be much easier. Let me take a little picture here. Okay. Okay, so you've got, oh, that might not have been a super duper good one to give you because you might not have known. Well, you should know how to draw that one. Okay, so you've got H to C to H, and you've got an H to H and an H to H. Okay, those are the reactants, correct?
Yep.
Because you have 2 hydrogens, okay?
Yeah.
And then you've got the product, you've got C, is that a single? Yeah, doink, 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 to C. Okay, and you've got only one of these, and you've got only one of these. Okay, so let's kind of count each one up separately. So you've got this, oops, this to this is 413. Okay, so you have 2 times 413, and this to this, you have 2 of those.
In there,
Is
432.
432. Okay, now this one is a triple bond. That's 839, and there's only one of those. Okay, so you're going to add all those up. Those are positive numbers. And then you've got 1, 2, 3, 4, 5, 6, 6 carbon to hydrogen, which is 413. And you've got 1 carbon to carbon, which is 347. Right?
Yep.
Okay. And all those are going to add up to a negative, and then you just add those 2 numbers. It looks like it's definitely going to be endothermic. No,
Okay.
it's not. Let me just double check. Okay, let's get an answer here. 6, 826 plus 2 times 432 plus 839. Okay, is that?
So I got a minus 296.
That's it. That's the one. Yeah,
Okay.
you're faster than me. Okay.
I had done it twice. I had done it once with 1 hydrogen to hydrogen, and then once with 2 using both the molar.
Okay.
And then
Good
figured
for
I'd
you.
ask.
Good for you. Good
Yeah.
for you. Yep. That's how you do
Okay.
it.
And then my final question has to do with Hess's law, and it's really it follows along the same lines of the products and the reactants.
Okay.
Why using Hess's law so because of the way that the delta H is calculated, you can't really take the 1/2 that was on the front. So you don't multiply by molar quantity as you're adding up the products and the reactants, because you just
Are you
combine the 2
talking?
equations.
Let me make sure I know. Do you have a problem number for that? Because
Well, it's problem number 5
okay, let me
on
look
the
at
quiz
that.
as well, and it also goes with that video that you sent.
Okay, okie doke. Now, let me do that one with you too, because I definitely have one of those on the test as well. Which that one would be a good one to put on there, just because Most people are just kind of maybe looking this stuff up and not taking the time to actually figure it out. I like to take those questions and change the numbers in case you haven't noticed. So, if you know how to do it, it's simple. But, if you haven't watched the videos or whatever, you're in trouble. And believe it or not, people don't watch the videos. Or, let's see if anybody else even joined in. Because it's right now it's only 8:00 here. So, all right. So you want to end up with this. I'm going to leave the phases out because it shouldn't matter for this.
Okay.
Okay. So that's what you want to end up with, right? And you're given these random equations. And those could be intermediate. So what people don't realize when they start studying chemistry is a reaction is not just a simple matter of reactants going to products. There can be many intermediate reactions that that you don't even test for, and they don't even last for more than a nanosecond. But people make a lifetime pursuit of figuring out those. I'm going to scoot that over. That's okay. This one is -16. I'm kind of running out of room there, so I'm getting lazy. Okay. And then the other one is 2H2 plus O2 to water. Okay, there we go. All right. Now, the thing that I noticed right off the bat is that I'll do this compound, we need to turn that reaction around.
Yeah.
Because it's in the wrong place. So I'm going to do that first. And so we reversed it. So we're going to make that positive 1685. And I'm not going to change the coefficient out front yet because I want to see, let's see, we want to end up with some water. This one I think is going to stay in the same order because that one's going to stay in the same order. Okay. Now here's the thing. We want, oh my goodness sakes. We're going to have to take half of that. So that's going to be 2/2, 2/2, 3/2.
Yeah.
Okay. Then, okay, that's 1.5 and that's a half. I think we're going to, oh my goodness sakes.
Take 1.5 of the other one.
I think so. Let's see, we want 3 halves. Yes. Okay. Think we want 3 halves. I think. No. Yeah. Because that's going to be 2 times. That'll work out. 3 halves of that. And whoops, I did that one backwards. Sorry. And 3 halves of that. Okay. So that gives us, let me go back to another color here. That gives us 3 water, which works out. Okay, we got the water taken care of.
Yeah.
We've got the W taken care of.
Yeah.
The oxygen falls out completely. What happened to the hydrogen? Where'd the, oh, there's the hydrogen.
Yeah, it should be good.
2, and that's a 3, and that's 1. Okay, so you're going to have 1/2 times positive 1685 and 3/2 of -477. Okay, so none of these coefficients are in that calculation. All that's in the calculation is those coefficients out there.
Okay. So I thought you could take, and this worked for me on the homework, so I think it's why it was confusing on the quiz portion. You could take like, because I know I need only one WO3, I thought I could just
Right.
take half of 1685
Yeah,
and have that be plus the 3H2O, so then 3/2 of 477, and then make the products positive and the reactants negative.
I think
But it gave
that'll
me this
work.
obscenely large number.
Oh, okay. Yeah, I'm not sure that that would always work because I don't, I mean, it lucked out that it did, maybe if it did work out, but
Yeah.
not necessarily. So it just happened that it did work out. But I think you would need to make sure that some of these, like for instance, you want to make sure that the oxygen cancels out, because if it didn't, then you'd need another entire balanced equation to figure that out,
Okay.
I think.
That makes
So
sense. It makes a lot more sense when you talk about canceling something versus just assuming it goes away.
Right.
Okay. That makes a lot more sense. The video was really helpful on that one too.
Oh, good. Okay. Anything else I can help with?
I think that's everything for me.
Now, wasn't it you that the other day, what was that, Tuesday? I don't know, maybe it was last week, and I said, oh, I think I figured that out and sent you an email or
Yeah,
something?
you did.
Okay.
I got that.
Okay.
I had gone through it too many times, so I ran out of retries, but I understand how to do it now.
Okay.
Yeah.
Well, if there's anything else before you take the test, I think the test starts Sunday and you have till Monday to do it. If there's anything
Okay.
else, just shoot me an email and I can make a quick video or whatever and send
Absolutely,
it to you.
will
Okay.
do. Thank you so much for the help.
You bet. Anything else?
No, I'm good.
All right. You have a great day.
You too. Bye-bye.
Okay. Bye-bye.